Okay, Bismillahirrahmanirrahim. Assalamualaikum. My name is Muhammad Fadrul bin Said, and then I want to talk about correction on SPT-N number N60 prime, a geotechnical engineering overview for standardized analysis. Okay, what is SPT-N correction? When doing a standard penetration test (SPT), the raw N value that we record at site is not yet accurate for engineering design. This is because the raw N value is affected by hammer efficiency, borehole diameter, road length, sampler type, soil overburden, and to get the standard comparable and meaningful value, a two-step correction is required. Okay, what is the step? Okay, first step is the step one is energy correction is N60. The purpose of this step to correct the field N value to a standard 60% hammer energy. Different hammer deliver different energy. For example, a donut hammer deliver only about 70% energy. So we use correction factor. Okay, the correction factor that we use is EM, CB, CS, and CR. Okay, what is EM? EM is hammer energy factor. CB is borehole diameter factor. CS is sampler factor, and CR is road length factor. Oh, I forgot. And N we use also. N is field SPT N number. Okay, the formula that we use is N60 equal to EM times CB times CS times CR and times N equal to over 0.6. This produce a normalized N value independent of equipment difference. Okay, and then we go to step 2 is overburden correction and prime 60. Even after energy correction, soil at deeper depth experience higher overburden pressure. Sand become denser at depth simply because of weight of soil above them. Whitman 1988 suggests a correction to bring oil value to a standard pressure of 100 kPa. The formula that we use is N prime 60 equal to N60 times square root 100 over effective pressure. Okay, where this effective pressure and then this step only apply to granular soil, which is sand. For the application correlation chart, relationship and prime 60 versus friction angle. This graph show the ultimate purpose of correlation. It allows us to estimate key soil properties. Because raw and value can vary uh, dramatically, without correction, two sites using different hammer may show different N value, even if the soil is the same. Then, designer may under design, which is unsafe, or over design, which is expensive. With correction, soil properties become comparable, friction angle estimation become reliable, and better and safer foundation design. Okay, for the next slide, this is example calculation. The problem is an SPT test record a field N value of 20. The test is at a depth where the effective overburden stress is 90 kPa, given the following standardized equipment factor. Okay, the EM, CB, and CR is fixed. EM is 0.7, CB is 1.05, CS is 1.0, and CR is 0.95. Okay, these are the step. We just use the step 1 and step 2. And then we just put the value into step 1 first. And then from that, we get 23.275. And then we use just 23. And then the answer 23, we put in step 2 formula. And then from that, we get n prime 60 equal 23 times 1.054 equal to 24.212. Okay, these are the value of N60 that we get from the problem. Okay, for the last slide, the conclusion and key takeaways. The first is accuracy. Raw N value can vary by up to 100% depending on the hammer used. Correction is mandatory for accurate soil profiling. Okay, without correction, N value can be wrong up to 100%. That is the meaning. And then for standardization, N60 provide a universal language for geotechnical engineer, allowing meaningful comparison of soil data across different sites. N60 standardized equipment different, and Prime 60 standardized depth, which is effective stress. Then last is safety. Reliable foundation and retaining wall design depend on corrected value. Using N60 prevent under design or costly over design. Oh, I forget. The corrected N value are essential for soil soil strength estimation, friction angle, and foundation and retaining wall design. I think that's all from me. Thank you for listening. Bye.